Hello.
Hello, everyone.
Hey guys. Uh, so I just have a couple of things from my side this week. I don't know if anybody has any other topics. Talked to Jeff a little bit. He's still working on from the Ventana side on getting the their proposal on um, the link layer to FDI mapping that they've done in the past. So for just doing the the streaming protocol. And so whenever he's clear on that, then we'll do a review on that and see where we are for that one. For the control path integration, I have been working with the doc and battling Google Docs. I think I've come to the conclusion that I'll probably end up using some Google Doc extensions. You know, if we want to keep this document in Google Docs, I'll try and use some of those extensions and just I don't think it requires, so most of the extensions that I've been dealing with don't require you to have the extension to like view the document or even edit it. But if you would like to get like the automated features, you'd have to also install the extension on your side. These are pretty popular ones. Here, let me share. I can show you what the names of them are. Da, da, da. Oh, sorry. One sec. So the extensions I think I'll end up using is this one called cross-reference. And that lets, so right now in the document, David made all of like the um, figure and table labels as headings, actually, which breaks a number of things in using other extensions. So I'm going to use this uh, cross-reference tool to turn all those into um, they're just basically hyperlinked behind the scenes entry headings or something like that, but not actually headings. So they're hyperlinked markups behind the scenes, and so that lets you do that, and lets you later on if you want to make a cross reference. So like the document that I wrote in Word has lots of cross references specifying specific figures and things like that, and so I will be able to you basically just use them as a normal cross-reference. So it'll, I'll put in basically instead of typing in the name of the figure, I'll just put down a markdown name. So like hashtag figure two or something like that. And then when it run the markdown script and it replaces it with the actual name of the figure. So I'll find some time eventually and get that integrated, and then I'll go back through David's stuff and convert that so the tools play friendly with the whole document as a whole. The other thing is this thing called Markdown tools, which lets you do automatic heading numbering. So I did not realize this until recently because I guess I just don't do enough stuff in Google Docs, but there's no automatic heading numbering at all in Google Docs. So, and if you want if you don't want to manually type these numbers in for each heading, then you have to use something like that. The problem with that is that it's not very selective. So every single heading gets a number. So if I run that, then all of these figures get a heading number in front of it, which is ugly and doesn't look particularly useful. So I have to do first one, then the other one in order to modify the document. Okay, yeah. So on that, that's it on the actual uh, the tech writing side. So on the
Related
technical,
to that topic, well, that's incredible. Thank you. Um, do you need some help? I remember you were asking for a volunteer because
yeah, if somebody else wants to try editing, um, I don't have travel right this second, but in the next month or so, I'm probably going to be out of the country one way or another for a good bit. So if somebody wants to pick this up at some point and keep running with it, then I'd love help.
oh, okay. So I don't know if people jumped up and down and volunteered last week, but
No,
okay. I can do that. Yeah, you have done an amazing job streamlining everything. I tried to offload you a little bit as much as I can.
awesome, thank you. Um, okay, all right, that's great. So I'll send you links to these extensions so you can get familiar with them. And then maybe we can talk through some point, what I end up doing to parts of the document, and then you can see if you how well you work with that flow and stuff.
Awesome. Uh, we'll find a time to chat together.
Okay. So the topic I talked about last week was, so like I said, Jeff is working on the streaming protocol mapping. And so I think there's still kind of an open on whether we really want to do other flit types for a link layer mapping. And so I still would like feedback from people that are doing controllers as to what your muxing capability is. Because again, there's no issue, um, muxing two different things like this, then maybe this is a a goal we shouldn't chase. But assuming that you do have to have to mux like with like on most people's controllers, I'm still looking at the 256 byte with optional bytes latency optimized format from UCIe, mapping the link layer onto that. And so last week I talked about um, oh, sorry, it's not. One second. Zoom is not cooperating with me. One second. Yeah, there it goes. So last week I talked about what you would do to the LLP in order to fit it more optimally into this format. And so the takeaway is the LLP would go into this format without any changes if you truncated the first granule, which is specifically meaning the header granule, because the header granule is I want to say 15 bits of well, 16 if you count the continuation bit. So 16 bits of data that, and then I want to say 6 bits of check bits, and the rest is reserved. And so, actually, do I have that? I have that right here. Yes, right. So there's this thing called the TLP start bit, and that has all of your, that basically what that means is just a bit field saying which granule in the LLP has a header in it. And I think it's constructed so you could potentially have more headers, but we have a requirement in Rev A right now. There's only one header in the entire thing. So there's a lot of wasted bits, but that's fine because it still lets us expand. But either way, and then there's one bit I want to say in the reserve section that's kind of allowed to be a bit 21 that is allowed. It basically says whether the LLP is continuing a previous LLP, which is a fuzzy feature. And then then there's header check and stuff like that. And so this proposal was to remove header check. And so because you have coverage from CRC, which is debatable either way. But either way, you really only have 16 bits of data. So I said, let's just do 16 bits here. That's what the green colors are. And then the orange / light orange are the actual LLP payloads. And I thought a little bit more about this while going back through the spec. And I guess I would like people's feedback. We don't have a lot of people on the call, but at some point, people's feedback on whether this misaligns the granules by 2 bytes. So I think ideally you're processing them in kind of byte order, and ideally where the granules are going to be aligned. But if you misalign granules like that, I don't know if that causes an issue for people, right? Because the granule alignment changes from well, it changes as the split is received, right? So you do have to be aware of that, in order to align to the granules. So I don't know if that's an issue.
Brian,
Yes, Ty?
I see that there are the reserved bits.
Yes,
Can't we drop them?
you can,
So
but that doesn't
then, yeah.
that only fixes one of the packets, one of the one of the LLPs, and it doesn't.
I see. Okay.
Yeah, you can't move the CRCs; those are defined by UCIe, and you can't move the UCIe header.
Okay, and
There's not a clean way of doing this, no matter how you slice it, unless I move the LLP headers to the end of the LLP, right? And then if you do that, then you
one
can't
question.
process the stream as it comes in. So if you have in using the terms that are in the, so I'm not sure UCIe has a definition for like system interface for these wires. On the FDI, because FDI's just got FDI wires. So, but if you end up with a smaller interface like that and you're getting a smaller fragment, if the header is at the end of the LLP, then you can't start processing the LLP until the entire thing gets there.
Yes.
Whereas if you get the LLP header at the beginning, you can kind of process these as they come in, even if your bus fragment size is whatever size it is. It could be a single byte, and you could still process them as in order if you do it like this.
So it's important to have the LLP at the beginning.
It is, well, conceptually it is. I don't know in practice it is. It depends on what people's implementations are like. And I honestly don't know how this differs on UCIe, whether these things are what width those are. I don't know. I need to look at FDI more.
And each line has a new, their bit 64, 65, 100, 128, and 29. It's
yeah, this is it's a 256 total, and the way that they're grouped in 64 byte chunks. But
So the
but this is
64
just
and
the way they're written in
65.
UCIe. This is like I took a diagram from UCIe and hacked it up.
Okay. Okay. So it's the same. It's a each line. It's a new LLP start, or it's the same header just spread across the data.
It's a new one.
It's a new one.
So this is 4 LLPs packed into a
Mhm.
flit. And there's an LLP, there's each green section would be a truncated LLP header. And so, yeah, so you can process this in byte order if you need to.
Okay.
So again, I need to look at this more from the FDI side. Again, if you're guaranteed to get the whole thing at once, then maybe moving the LLP header to the end is acceptable. So I've concerns with that, but maybe that's an option. And then the other side is if people really don't care about granular alignment, if a granular alignment's able to change from the first chunk to the next chunk, then again, maybe it's not an issue. The other thing that I thought about here was ECC versus CRC. So we have both right now, and some parts are covered by ECC and some parts are covered by CRC. And so I looked a little bit into other protocols that have both as well. So PCIe 6 has this, right? And the way that they use it is it's just, it's additional error resilience in the traffic. And you process your ECC, and then after you've done all your, single bit error corrections, then you go back through and and then you check your CRC on that corrected output, right? And so it gives you you're able to handle a lot more errors than you would otherwise, or error detection.
Yes, and also as we discussed last week, the ACC gives you an option for correction, not just detection.
Correct. And so I started looking at, okay, well, if we assumed that this is a fresh flit and that the LLP starts on granule 1, which is right here, where's the ECC, and what does that look like spread across this? And so I just highlighted where the ECC bits would be in the stream as in this hypothetical. And so like you could, again, if you're able to process in byte order, you walk down the first couple of headers, right? You know where the LLP starts, right? And then you can just start processing ECC as it goes. And as you process ECC in the same pipeline, you process CRC, you calculate your CRC. And by the time you get to the CRC check bits, right, you have both the error corrected data and the computated CRC for the corrected data by the time you get to the CRC check bits. And so at least for that half flit, you have all of that error resilience, and then you start that again on the next half flit. And UCIe has protocol handshakes for if you get like half a flit and things like that, And so, but the problem here is that CRC checking and CRC retry happens below FDI. It happens in the die-to-die adapter layer. So if you do this, you have to have your half of the bits, or half of the error resilience, the ECC part, is being calculated in the protocol layer, and the actual potential response to it is happening in the die-to-die layer, which is a bit asymmetric, right? So it would be kind of an extension to the existing UCIe, it would not be a normal feature that you would see in these controllers. So it's a little fuzzy whether this would ever happen, right? But I figure we can give people guidance that, if we offer this flip format and you want the extra error resilience, this is where you need to do the ACC if you want it to actually have any meaningful impact. Your other options obviously are just to turn off CRC and you don't turn off CRC necessarily, but you turn off the retry mechanism, right? And just handle errors in ECC, and you just don't have any error coverage for those green, yellow, purple, and blue blocks in the diagram, but you're what, 90-something% of the bytes have ECC correction on them, right? So your error resilience is still pretty high if you just turn off error handling in die-to-die adapter and you only handle it in the protocol layer. I think the CRC check pick the check still happens and things like that in most controllers probably. So really what you're turning off is retry, right? And you're hoping that the errors that happen in the bits that you have error correction for, and that you don't have too many errors. If you end up with an error that is unrecoverable in ECC, then it's a bus error, and you have to well, the bus state's bad, and you have to deal with that however you deal with that. The other option here is you just you keep CRC and retry, and then if you do that, then there's really no value to even processing ECC on the receiver. So my statement from a spec perspective is that the transmitter is always required to generate both types of bits, and it's receiver's decision whether they do anything with them. And the receiver, depending on the complexity of their controller and their protocol layer, has a number of options on how they respond to both ECC and CRC.
Okay, then you must both of them must remain, so you can't drop them if you
We
say
can't.
that,
Well, I mean,
because if
we are
transmitter,
redefining LLPs. Technically, we could drop them if we really wanted to, but I don't. It's not like we're going to fit an extra granule in here. I don't think. I mean, I don't know. No, maybe. Yeah, you're not going to fit any extra data in there, right? So aside from like the power that you spend on the ECC logic, right? There's no real waste. And I don't think we want to redefine the LLP to pack more granules into like asymmetrically into LLPs, because I guess you could do
no, I'm
16
not
granules
suggesting
per
what was.
LLP instead of 15. I guess that's an option, but I don't know how divergent we would like to be here. I guess my preference, at least in Rev A, would be to, because we're not changing any of the functionality in the rest of this document. We're just reformatting. So I think this is still kind of a Rev A 0.1 or something like that. It's not a Rev B, right? So if we're talking about Rev A of this extension, I would just say, leave the ECC in there. And then if this becomes a really popular thing, maybe we make those, we like consolidate things and give an option 2 in Rev B or something like that.
Are the ECC bits, they're actually in the payload, or are they in the LLP header, the green?
They're yeah, this is a confusing part of the spec. They're in the LLP, but they're talked about and dealt with as part of in the context of the TLP. So, but they're technically part of the LLP. So they're basically, you take a TLP and then you make a hold on, let me just share this diagram.
It's okay. It doesn't matter. I think it's.
It is interesting.
I was just trying to understand your formats there, like how you're describing what's in the payload, what's in the headers, and all that.
Yeah, it is confusing. And so I actually, because it's been a while since I've read this spec, and I looked at it for a while, and I'm like, wait a minute, what does this actually mean? Okay. So, okay, so we have this thing called the protocol layer packet, which is the encapsulations that we do in the bus protocol variants. And it is it's a data payload that typically is a single transaction from a bus protocol. And you add a TLP header on it in order to define the type, and that's your TLP. Going in the TLP, then you make a new type of packet called a protected TLP, which adds ECC it breaks up into 2 code words. One of them is 32 bits. So it's basically your TLP header, which is like 12 bits plus some payload plus some ECC is your, you know, is your TLP header, right? And then every 128 bits, I want to say, we have another ECC. That's your large code word. Every 128 bits or so, we have another ECC byte. And then that protected TLP is basically the new TLP that's then quantized into granules, and you add you take that quantized LOP and then you add a header granule to it. And so the end
Yeah, so it's in the payload. All the stuff's in the payload.
it's in the payload, yeah, sort of, because it's the
That's fine.
it's in the it's in the protected TLP, right? Which is kind of like this intermediate format, right?
Mhm.
And so so this is the actual LOP format that you actually end up transmitting. And so there's the first granule is your header, which is, again, my proposal is to turn that into kind of a half granule, which, again, not sure that breaks anything. And then the rest of them are transmitted as granules normally, which are 32-bit granules. And so again, if we want to recover that ECC data, then you end up changing the definition of the protected TLP to a different width. And so you granulize differently and pack them in the LOP differently. Again, if we're redefining LOP, maybe that's not the end of the world, but I think I'd prefer just to keep that to just a minimum, that makes sense in terms of efficiency and not stretch too far.
Yeah.
Again, I think, as to your point, Jeff, I think when we had an email conversation, I also am not 100% sure that all of this effort is needed. So that's why I've been reticent to jump in and start writing a whole bunch of text around this. So you can still consider this all pre-work for that. So I'd still like to hear from people if you can freely mix and match, flip types with streaming, that would be ideal, and we don't have to worry about it. But if you can't, then this is an option people can use.
The other question I had on the format you're proposing for packing in this 256 byte is it going to affect how we have the, protocol invariants?
No.
Those mappings, are we going to be less efficient in any way? Because it's got an extra CRC data in it, right?
So all of the bus protocol variants are defined with here. So it's based on the LOP size. So as long as you're not redefining the LOP, then if you're not redefining the LOP and you're not removing the ECC, then the amount of payload that you get per LOP is the same, right? You just get 4 of them, right? And so all the bus protocol variants, at least the ones that I worked on, David and I worked on a spreadsheet, and he gave me like a version of this chart, and we kind of did a little Excel magic, and picked bus protocol variant options, like AMBA bus widths and things like that gave us a reasonable utilization of the payload for the given LOP size that we have. If we redefine these things and you end up with more, because the problem with LOPs right now, especially in Rev A, is you only have one header, right? So I'm not packing more than one. I can't have more than one TLP and an LOP, right? So for a given 64 byte chunk, I can't have like you can have two LOPs in, sorry, two TLPs in the LOP, but you can only have one header, right? So you can have like, 3/4 of one and 1/4 of another or something like that. So long as there's only one, the headers at, towards the end, and it's not, there's only one header total in the system. So, which is fine, right? And you can end up spreading potentially, you can potentially have actually, I don't know if you can have one without a header. I think you probably still have to have an idle header. But regardless, it's all based around those numbers anyway. So us changing.
But you're changing the payload size though, right? Because you've got overhead for CRC and the ECIE.
No.
In the
No. Well, those are, so again, well, let me reshare.
I think.
Yeah, let me go back to the diagram. Every time I switch, it has this crazy thing with Zoom where it takes like forever to actually show my windows. All right, so you see the orange bits, orange groupings, this is an LOP kind of as defined in the spec. This is the LOP payload, right? The header is normally 32 bits, but I've truncated it down to 16. But the actual payload of the LOP is unchanged from our current definition of an LOP. You just have 4 of them, right? So at least from assuming we don't have any problems truncating the LOP and having, a half granule headers basically, then your actual payload size for a given LOP is the same. The only waste in the system is, there's 16 bits of reserved, which I'm sure we'll use at some point. But there's not a difference here that you would have to remap.
Okay, so the ramifications of truncating the LLP header is that we have less LLP types, or
No, those are all basic. So what I've truncated is the reserved bits, which we're not using, and the check bits, because we don't need ECC on the header if we have CRC. We just lose a little bit of error resilience.
Okay.
Again, so you don't lose anything in this right now as it's presented right now. You have to deal with unaligned granules, because the granule alignment is different from the first fragment, if you want to call. I don't know if UCIe has this 64-byte name for the 64-byte chunk, but like for the first, if you want to call these rows fragments in the parlance of the transaction layer spec, the first fragment, aligns its granules based on the first byte. The second fragment has a half granule, and then basically the rest of the granules are half aligned for the next couple. And again, the reason for that is so you could get the header bits out the interface first before you get the rest of them, so you can do ECC processing properly. If the fragment size is sub 64 bytes. If the fragment size, I need to look at FDI. Maybe there's something here that makes this completely unnecessary. But if the fragment size is less than 64 bytes, then you may end up getting TLP payload, and you put the header at the end in order to make it granule aligned. Then you end up with getting payload before header, and so you have to buffer your payload, then process the header, then process the payload. Well, I take that back a little bit, because you can kind of infer, because this is the preceding one, as this and this one's aligned, then you can infer. Well, there's a limited amount you can infer without the header. You can infer like the what would be the one, what's the word? One protected. One large code word. That's what you can infer. So like the first handful of bytes, you can infer where the ECC is based on the previous one, but based on the previous header, but you're very limited. So again, it's the same problem. So if your fragment size is less than 64 bytes, then you can't start processing in the pipeline until you get the rest of it, because you need the header to know how to align your the rest of the granules in terms of, where the header is, where the ECC starts and stuff. So that's why it's ordered like this. And unfortunately, I can't move the UCIe CRC in this. So there would be a bunch of caveats. And like I was saying earlier, maybe before you joined, Jeff, too, some of this is a little fuzzy because in order for ECC to make sense, you have to process ECC before you do CRC, right? Which you can be pipelined. But CRC checking and retries to RDI happen in the die-to-die adapter layer, right? Which is within the purview of UCIe, right? So we'd have to suggest an extension to UCIe that says, process the ECC before you do the CRC. Again, if you're receiving these in byte order, there's really no problem with that, right? You can do that very easily. But again, that happens in what we've been considering the black box.
Is that in the scope of OCE though?
I mean, I don't think we're gonna like bend over backwards here, but I think we could suggest this as a feature and then people could implement this. I don't think we're actually defining like an FDI extension or something like that.
Well, but if we say that we resolve ECC before it goes into the FDI layer, then does that contain the scope within OCE?
We never really finalized a scope.
Yeah,
I don't know.
I don't, if we can avoid having to, have a change order in UCIe, I think it'd be helpful, right?
Yeah, again, I don't think this is something that we would pursue in terms of, well, I take that back. If this became very popular, I think it's something that we would something we might want to consider. But I don't expect this to be like super popular right this second. So I think at most what I'm thinking of is a notation in terms of implementations that, if you are implementing a custom die-to-die adapter layer and are protocol aware, doing this gives you additional error resilience. That's what I was thinking of right now. If people actually wanted to formalize that, you would probably need an additional signal at the FDI layer to say, to enable, disable, to enable or disable the ECC, because like UCE doesn't have like registers there. They just do everything through wires, right? So basically it would be a single wire saying ECC, signifying, or either that, or we would define a new flit type, and that flit type would also include that, part of our link layer processing. So those are two ways you could do it. And I think, but I don't see a reason. Again, for both of those, again, I think we could provide text and say, if people would like to make an extension, these are ways you could do it. But we're not proposing a specific new flit type. We're using their flit type, and we're not proposing an extension to the wires right now. Though any custom implementation could do this. And the thing is like, you're not really breaking the UCIe standard, because this is kind of still on top of UCIe. It's just adding more awareness to what is the payload in the die-to-die adapter layer, right? So you wouldn't be able to do this defaultly, but again, if you're doing an extension that enables or disables this, I don't see a problem being UCIe compatible with such a thing. I definitely don't see us requiring it. But I guess to this point though, a system doesn't have to do this, but if they don't do this, then the ECC really has no value. Unless you turn off retries. If you turn off retries and you just absorb errors at the protocol layer and hope you can correct them with ECC, right? Then you could potentially get, similar error performance, because it's going to be, most of the bytes will be covered by ECC, and not have to potentially do retries. So you end up with most of the error resilience benefit and potentially more performance. But it's a risk, right? Because you're not fully covered, and so you could end up with an unrecoverable error. But you'll get the CRC error either way from FDI, and so so you'll know if it's unrecoverable at the protocol layer, and you just have to be able to handle that from a system layer.
Okay.
Okay. All right. So yeah, I think that's all I got. So like Jeff, again, before you got on, I told everybody that you were still working on your side to see if you guys could donate what you have so far as a starting point. And so I think we are waiting on that from the streaming side. And then everything else is tech writing for me.
Yeah, from the raw format you're talking about.
Yes, yeah, for raw.
Yeah, I'm working on that. Hopefully by next week I should have an answer.
Great. And if you guys can't donate a spec, if you could donate some of the conventions you use, because I think, some of the things I talked about with David were inferences in the UCIe spec in terms of byte orders and things like that, and I've been doing some reading, but, I really, I'm personally not writing a controller, and while I'll get probably feedback from my guys, having your guys pre-work on, byte ordering or whatever, even if you can't donate the full spec would be, is really kind of the bulk of the work I think of on this. So, if you can share some details about decisions that you guys made, that would be very helpful as well.
Okay.
So Brian, I have a quick question here, right? So we are using the flip format from UCIe and whatnot. Do we know if we have permission to use those flip formats?
Do we need permission?
I mean, ARM used it for.
Well, so back in the day when I was trying to build a link stack for my previous company, I did approach UCIe to see if I can use their flip format. And the answer at that time was no. But I don't know. I mean, I don't know what are the legal aspects to referencing stuff from UCIe in our BOW spec. So maybe someone should also check on that.
I mean, the only thing that they would have a legal issue with would be trademarks in my mind. So because we're just saying use this flip format, and then we're saying here are the bytes that are reserved by UCIe, here are the bytes that we're using, and then if you need to have information about how the UCIe bits are filled in, and how any of the non-payload bits are filled in, then go reference that spec. So like our reference is really just the trademark UCIe and the name of the flit. There's really nothing else there. I mean, and we're also not giving we're not giving any kind of like reference code or anything like that. So like their CRC calculations not in our spec, their header format's not in our spec. It's just like you go look at the flit format from their spec and you compare it to ours. And this is how we're basically saying this is how you pack it into the payload. And like Jeff said, ARM did the same thing in their C2C spec, and here I can show you how they documented that real quick. It's really terse, right? Which is probably by design.
Yeah, I kind of agree with you on that. I mean, as long as we are not utilizing any field from their flit format into our adapter layer, I think we are good. I mean, we are basically what you're saying is we'll just use that as a bit stream, and even though the bit stream has a certain format defined by some outside spec, all we are showing is how we map that bit stream to up to our adapter layer. So I think if as long as we are sticking with that, I think we should be okay.
Right. Yeah. Well, at least from the flip perspective here, I think that we depending on what we do for the actual FDI mapping, there's probably some additional discussion on behavior of of that interface. And so we'll see what Jeff comes back with in terms of detail there. So I don't actually know, because we need to find, this is something we'll need to define for ourselves here, you know, because our link layer, you know, it defines packet formats, defines granule orders, things like that. And then it gets down into the weeds about how you interleave stuff and fragment sizes and things like that, right? And so we have to basically decide where in that chapter, or where in those, you know, those chapters, where we're kind of drawing a hypothetical line about where FDI fits, and then writing our appendix or whatever, or a new chapter saying, all right, start from here, or basically just start from the LLP side. Here's how you remap the LLP. And then for all the other things we talk about in terms of byte order handling, granule processing, that kind of thing, here are our assumptions in terms about, excuse me, here are assumptions for FDI signaling. And so I don't know if those have additional legal implications. So, but, you know, I mean, I feel like lots of people make these controllers that implement FDI, and I don't think they all have to be UCIe members in order to implement a FDI, a protocol layer controller. So maybe this is something we need to solve at a higher level, and maybe we need to, or maybe it's a question we need to ask at a higher level. And there may be, just like we just talked about with the packet formats, there may be language that we can utilize in such a specification that is how to say this, conveys the behavior that we want without naming specific wires and things like that too. So that's another way of doing it. Because most of like the UCIe wires they're almost like configs, in my opinion. I mean, you have in-band stuff, right? Like, you know, sometimes the error is pertaining to the packet and stuff like that, but sometimes the wires are just, you know, they're like setup, right? They're just in lieu of registers and stuff like that. So for a lot of that stuff, you can just specify, you know, FDI controller should do, you know, X, Y, and Z in order to be compatible with this. And you can name those configs without saying, all right, this is the signals for each wire or two. I don't know. There's a couple of ways we can do this, but I don't think this is I don't think any of this is probably an issue. And hopefully there's not like you said earlier, as long as we keep it to the payload level of we're showing how we're utilizing FDI rather than like defining anything else within it, then I think, and then the die-to-die adapter layer, then I think that we're fine.
Agreed.
So Brian, are your thoughts that we would tackle the, let's say, chai C2C binding with, you know, protocol variants? Would we handle that in this group, or?
That's where we've done it in the past.
Yeah.
You know, in terms of doing just the bus protocol variant itself.
Yeah.
Yeah. Yeah, I haven't actually thought about it or looked at it yet. So yeah, I mean, but we could do it in this group. It should be pretty straightforward.
Yeah, because that would be the other piece of, you know, that we could deliver that would correspond with the raw format binding, right?
Right. Yeah, I haven't looked at the alignment, whether it really aligns or not. Like you had pointed out before, we have CXS and things like that. So, but again, yeah, I don't know. I need to go pull up those old spreadsheets and look at what the payload looks like on Tri-C2C. They have very different granule sizes. Like they're 20-bit granules, and we use 32-bit granules. So like a lot of their decisions in terms of like payload sizes are a little different. So there's going to be some waste. But I need to go double check to see how it packs. And I don't know if there's any. I don't know why. Again, I'm familiar with chai, but I didn't I didn't pay too much attention to C2C, so I'm not sure how many fields are optional and stuff. So anyway, I need to go look at it.
Okay.
If you have a proposal there, then by all means, I think we can discuss it.
We do not at this time. So I don't know if anybody else in the OC community would have input there.
Yeah, I assume if anybody's using C2C nowadays, they're probably using it on UCIe, and they're probably using the binding that we just saw.
Mhm.
There's not a lot of reason to have another one at this stage. So ours would only really be if you're trying to do muxing at a higher level too, which is a use case. So there's no reason not to have one, but I'm just saying I doubt anybody has tried to do that outside of us.
Yeah. Okay.
Okay. All right. That's it from my side. Any other topics people want to hit on? Okay. All right. Thanks a bunch. And Jeff, if you do get permission to share this week, if you could send that to the group, or, again, if you don't get the whole spec, summary of decisions and reasonings would be awesome as well. But either way, if you could share that so that we could read before we meet, that would be really cool.
Okay. We'll do.
All right. Thanks, guys.
You.
Thank you.
Bye now.
Bye.